program. On the line with us, our old friend Michael Mann, Dr. Michael Mann, the distinguished professor and director of the Center for Science, Sustainability, and the Media at the University of Pennsylvania, the author of numerous books, most recently Our Fragile Moment, How Lessons from Earth's Past Can Help Us Survive the Climate Crisis. Michael Mann with 2Ns.net is the website, and Twitter handle Michael E. Mann. Dr. Mann, welcome back to the program. I wanted to, James Hansen's most recent paper, it appears to me that what he's saying is that if it weren't for the aerosols that we're throwing into the atmosphere, the particulate matter that is reflecting sunlight back out, that warming levels that would approach what we saw during the PETM. Am I misinterpreting that?
Hey, Tom, it's always good to be with you. I think that the Hansen et al. Paper has been widely sort of misunderstood in a lot of the coverage. And so I think the actual scientific message has been somewhat lost and distorted. And I think there is a lot of confusion about what it actually claims. And the basic premise of your question or your point is correct. There is this additional warming that has been masked by sulfur dioxide pollution, particulate matter that reflects back sunlight and so has a cooling effect. And as we clean up the environment, as we move away from dirty coal burning, for example, which has been the case in Western countries, there's still a fair amount of dirty coal burn in developing countries like India. As we move away from that, we're removing that masking cooling that had been present. And so there's an extra bit of warming there. It is probably in the range of a few Celsius, a half a degree or so Fahrenheit. So that's the extra warming that we would get on top of the warming from carbon dioxide pollution. But what's also true is that we get cooling from the disappearance of black carbon. Black carbon also comes from coal burning. It absorbs incoming sunlight, and so it has a warming effect. And so as we get away from dirty coal burning, yes, there's less of that sulfur particulate pollution, and that's a warming effect, but there's less of that black carbon, and that's actually a cooling effect. And we also expect other greenhouse gases, not just carbon dioxide, but methane and nitrous oxide, surface ozone, which is a surface pollutant from photochemical smog. We expect those to also come down as we sort of phase out those activities. And so the net effect is that all of those other things, at least to first order, pretty much cancel. And what we're left with is the warming from the carbon dioxide pollution. So we need to keep our eyes on the ball. It really is the carbon dioxide from fossil fuel burning that is primarily the problem when it comes to sort of the committed warming that we face. And there's a little bit of good news here, too. There was another study that came out actually a week later, a week after the Hansen et al. Study, that shows that there's increased confidence now in the conclusion that when we bring carbon emissions to zero, the surface warming stops. And so there is this immediate consequence of our efforts to decarbonize our economy. And there's a little bit of good news there. As I like to say, the truth is bad enough. The truth is that the planet will continue to warm, and all of these impacts will continue to get worse as long as we continue fossil fuel burning. It isn't that tough. What we have to do is to stop doing that, is to get off fossils as quickly as we can.
Yeah. Well, there's this globally absorbed solar radiation issue. I mean, the fact of the matter is the sun is still throwing heat at us. It's sort of like, your body produces heat, right? And you're laying in bed and you got 2 blankets on you, and that's just right. And then somebody comes along and puts 2 more blankets on top of you, and suddenly you're too hot. If they take
or a
away...
dog. Your dog
exactly.
To sleep on you. Yeah.
Exactly. But at that point, and then they say, for the next year, I'm going to put another blanket on you every week or every month, and pretty soon you're going to end up with 10 or 12 blankets on you, and you're going to be really too hot. But if you've got 8 or 9 blankets on you at this point, and the person who's dumping them on you in this imaginary hospital bed or whatever says, okay, I'm going to stop now, no more blankets, you still have too many blankets. I mean, it's still too hot. Isn't that kind of where we're at with all this carbon dioxide in the atmosphere? I'm seeing these numbers from from NASA. This is from the CERES, CERES, the satellite thing. And it shows that the amount of solar radiation that the Earth absorbs right now is more than 2 watts per square meter higher than it was just in 2009. I mean, that's pretty breathtaking.
Yeah, I mean, so there are a number of things going on here. We're sort of melting the ice. And as we melt away ice, the surface of the planet absorbs more of the incoming sunlight. And that's one of the important positive feedbacks. That's why...
Which is not a good thing when you say
Which
positive.
is not a good thing, right? Despite the name. It's an aggravating effect. It is a, it's a vicious cycle, if you like. And so that's built into the climate model. So that is part of what the climate models predict. And you're absolutely right about the blanket analogy. All else being equal, there would be this, what we call thermal inertia. The fact is that the surface would continue to warm up for some time just from the carbon pollution we put into the atmosphere. And that's been understood for some time. What we now understand from somewhat more sophisticated Earth system models is there is an offsetting factor there. And the offsetting factor is that when we stop putting carbon pollution into the atmosphere, the level of carbon dioxide slowly starts to come down because the oceans are absorbing some of that carbon dioxide and the plants on land are absorbing some of that carbon dioxide. So there is this blanket effect, this thermal inertia that would cause but then there is this drawdown effect which actually would cause some cooling. The two things nearly cancel out. And so what you're left with is that when you stop putting carbon pollution into the atmosphere, the surface of the planet temperature that you're at. So the bad news is it's going to be hard to cool the planet back down. The warming that we've seen so far is pretty much baked in, at least for decades to come, unless we engage in some sort of technology to actively draw down the carbon using artificial means. But what is also true is that the surface warming, which is behind the intensification of these weather events that we're seeing, stronger hurricanes, that will stop getting worse when we stop putting carbon pollution into the atmosphere. So again, there's urgency. We need to do this quickly. We need to decarbonize our economy very quickly if we're going to prevent a catastrophic 3-degree Fahrenheit warming of the planet. There's a shrinking window of opportunity to do that. But there's also agency. It is still possible for us to do that.
You just said 3 degrees Celsius, or are we changing the
Fahrenheit, 1.5 Celsius, okay. 3 Fahrenheit.
Okay.
Yep.
Now I'm also, again from this CFSV2 average T anomaly temperature 1979-2000 base, again from NASA. The northern hemisphere is 1.7 degrees Celsius above the 1979 to 2000 average, and has been for 139 days. It's a record streak. Now, this is not, a brand new global annual average. It's a streak that appears to be tied to El Nino and heat coming out of the ocean. But what does this mean?
Yeah, I mean, so what it means is, that 1.5, and again, I want to make sure to clarify the numbers because it can be confusing. We often talk about 1.5 Celsius. We tend to still think in Fahrenheit here in the States. And so that's roughly 3 degrees Fahrenheit. But that 1.5 Celsius number, when we talk about the devastating consequences of exceeding that amount of warming, what we're talking about is the trend line. When the trend line permanently crosses that threshold, then we've baked in some truly devastating consequences beyond the damaging effects that we've already seen. But before that happens, we're going to cross that threshold temporarily. We've already crossed it. Months ago, we crossed it, for the first time for a month. Now, we're crossing it, say, for several months in a row. The real problem will be when we cross it permanently, and we can prevent that from happening. So yes, the Earth will temporarily exceed that 1.5 Celsius threshold because of the extra spike of warmth, for example, from an El Nino event. It'll temporarily go above that, and then it'll come back down when that El Nino event ends. What we're really worried about is when it doesn't come back down, when it's permanently above that level, when the trend is 1.5 Celsius. And that'll happen in a matter of 1 to 2 decades if we don't bring those carbon emissions down dramatically. So we can prevent crossing that threshold. But the window of opportunity to do that is getting shorter and shorter.